Go. Alright, so today we'll be looking at the kinetic molecular theory. When we talk of the kinetic molecular theory, I think we're all familiar with the fact that when we talk of kinetic, we're simply dealing with motion. And then when we talk of molecule, we're basically referring to the fact that a molecule is the smallest particle that is capable of independent existence, and then these molecules are made up of even tiny particles called atoms. When we talk of the kinetic molecular theory, there are basically three principles that govern the kinetic molecular theory. The first principle is that all substances are made up of molecules. The second principle is that molecules move in a random chaotic way, meaning they bounce into each other. They do not have direction in which they specifically move. Molecules interact with each other. So basically these are the three principles that govern the kinetic molecular theory. When we talk of substances in this case, we're basically referring to the three states of matter that we know, which is the liquid, solid, and the gas state. So today, our main interest for today is deriving the formula for the pressure of molecules in a gas. Why specifically in a gas? Well, the arrangement of molecules in a gas is such that the molecules are capable of free movement. They can move. There's a lot of space in between the molecules, so there is free movement. That is why it is easier for us to look at how molecules in the gas interact with each other. So with each other and the surroundings in which they're enclosed. So today we'll be looking at the pressure of molecules within a gas. We'll start from the basic things that we know. We all know that pressure is equal to force over area. And then from Newton's second law of motion, we remember that our force here becomes equal to mass times acceleration. And then we can say from here that acceleration, when we look at when we remember the laws of motion, we can say that acceleration gives us a change in velocity over a change in what? Time. Replacing this formula where we have acceleration in the force formula, we obtain something like force is equal to mass multiplied by the change in velocity over the change in what? Time. This here on top gives us what we call impulse. Mass multiplied by the change in velocity gives us what we're calling impulse. Therefore, we can write the force as equal to change in impulse over change in what? Time. But then, we're talking of a certain molecule. We're looking at a specific molecule. So let us look at how this specific molecule is changing velocity as it is moving in one direction. Let's assume we're having the x-axis here, and then this is our positive direction, this is our negative direction. And then we're having a molecule that is moving like this. When it hits this wall, it bounces and it goes in the opposite direction. So we can assume that this is v1, this is v2. Therefore, when we talk of the change in velocity here, we can notice here from here that when we talk of change, we're talking of subtracting the difference between two quantities. So here we can find the difference between the two quantities for us to find the change in what? Velocity. Since this is going in the negative direction, negative times negative will give us what? 2 positive velocity. This tells us that there is a 2 change in what? 2 change in velocity. Therefore, we can put a 2 in front here, which gives us that there is a 2 also here. From here, we try as much as possible to remember these formulas where we are saying force is equal to 2 times the change in impulse over the change in what? Time. We also have pressure, which gives us force over what? Area. And then our specific interest is looking for the pressure of a specific molecule. So from here we can say, let us take the example of a cube. In this cube is filled up with air. So what is going to happen here is that the gas in this cube has a certain number of molecules. We are going to take this as our y-axis, this as our x-axis, and then this as our z-axis. Our main interest is for a certain molecule. Let us assume that this molecule is moving along the x-axis. We are having three different axes here. So when we talk of the x-axis only, it means out of the total number of molecules here, the number of molecules that are moving only along the x-axis is 1 over 3. Since we're having 3 of these axes, we're going to use the letter n to represent the total number of molecules. Therefore, along the x-axis, we're saying we're having 1 over 3 times the total number of molecules moving along the what? X-axis. But then we do not forget here that in the x-axis, we're having two directions. There's this molecule that is moving in this direction, and then there's another molecule that is moving in the opposite direction. Our main interest again here becomes is related to the fact that we are only looking for a specific molecule. So this specific molecule is only capable of moving in one direction only. So from here, we are going to say that for us to find the number of molecules that are moving only in one direction of the x-axis, mind you, this is telling us of the number of molecules that are only moving in the x-axis. It means this direction and this direction. But when we talk specifically of this direction, we are going to say, since we're having two directions, we're going to find half of 1 over 3. Half of 1 over 3 is simply saying 1 over 3 times half, which gives us 1 over 6. N. So we keep note of this. This is the total number of molecules that are moving only in one direction along the what? Along the x-axis. From here, we look at the number of molecules. The number of molecules is given by the formula, the number of moles multiplied by the what? By the volume. Let us look at a cylinder. What is happening here in a cylinder is this. When we talk of the volume of a cylinder, the volume of a cylinder is simply the area multiplied by the height or the length in this case. So we are going to say this is my L, and then this is my area. From here, we know that there are molecules within this within this cylinder. These molecules are moving with a certain velocity with respect to time. Therefore, my length here becomes, my L becomes equal to velocity times change in what? Time. And then my volume becomes change in S, which is area, times volume times change in time. From here, we can now safely say that the number of molecules becomes equal to, N is equal to this times the change in area times the change in time times the velocity. And then remember, we are looking for the pressure of one molecule that is moving only in one axis, in one direction of the x-axis. So we are going to say for this specific molecule, you are going to have 1 over 6 times the number of moles times the change in area times velocity times change in time. Going back to the formula that we have derived, going back to this formula, we can now safely say, when we are looking, this is the number of molecules that is moving in one direction of the x-axis. So the force for this is that we are going to multiply this times the force that we have here. It will give us the force that is possessed by this specific molecule. So we can now simply say force is equal to 1 over 6 times the number of moles times the change in velocity times the change in area times the velocity times t over change in time. This is multiplied by what we have here, which is mass times change in what? Velocity. So we can see that this cancels out, and then we have a 2 somewhere here. This becomes a 3, this becomes a 1. Therefore, the force becomes equal to number of moles times change in area, velocity times velocity becomes v squared over 3. So basically, this is the force that is possessed. Sorry, we have forgotten the mass here. This is the force that is possessed by this molecule that is moving only in one direction of the x-axis. From here, our main interest, remember, is that we're trying to find the pressure that is possessed by this specific molecule. When we go back to this formula for pressure, we can replace where we have force on top here. We can say pressure is now equal to, let me use the green marker, pressure is now equal to the number of moles, which is the force, times the change in area, times v squared, times the mass over 3. This is divided by 1 over s. This s that we have, which is the area. So in this case, we notice that these two cancel themselves out. In the end, we've derived the formula for the pressure that is obtained, or that is possessed by let me put the mass here, times the number of moles, v squared over 3. This is the formula for the pressure that is possessed by a specific molecule that is moving in only one direction of the x-axis. So basically we've derived the pressure for this specific molecule.